Welcome to solverfy.
.42. So we're playing around with a couple of scales and a container of water and a rock. And so the rock has a weight of 10 newtons in air. The container of water has a weight of 10 newtons. Now when we submerge the rock underwater, but it's not at the bottom or anything, its weight is 8 newtons. And we also then let it sink to the bottom, and we want to figure out what the weight reading on this scale is at that point. And we want to find out what the buoyant force on the rock is in situation B here, and also what the scale reading is. So the buoyant force acts upward due to the volume of water that's displaced, and the force of gravity acts downwards, and the scale is going to read the sum of those forces in terms of them being, vectors. So the buoyant force is just going to be the difference between these two readings, which is 2 newtons. So the scale reading here, we have the 10 newtons of water, and then we have this rock, and a 2 newton force is being directed upwards against it. And so just from Newton's third law, we know that there's going to be 2 newtons of force directed downwards in the water. And so the scale reading in this case should be 12 newtons, because even though the 10 newton rock is submerged in the water, the only way it can exert any force is through the Newton's third law sort of equal and opposite force against the buoyancy. Now in part C, the rock is resting on the bottom of the container, and so all of its weight acts on the bottom of the container. And so the scale reading here is just going to be the sum of the two weights, because now it's not being suspended buoyantly. And so the scale is going to read 20 newtons.